What truly unsettles the West is an arrival that rose under perfect conditions. It's a country boxed in by sanctions, cut off from supply chains, and still pushing forward anyway. That country is Russia. For decades, large jet engines were considered an exclusive Western domain, controlled by a small club of manufacturers that set the rules for global aviation. But quietly, far from airshows and glossy marketing campaigns, Moscow has been working on something that challenges that assumption. Its name is PD-26. And while it hasn't flown yet, the very fact that it exists is already forcing uncomfortable questions. The PD-26 isn't just another engineering project. It's Russia's clearest attempt so far to reclaim independence in one of the most complex industries on Earth. Developed under the umbrella of United Engine Corporation, the engine is designed as a high-bypass turbofan, producing roughly 26 tons of thrust. That number matters. It places the PD-26 squarely in the wide-body category, a space long dominated by Western engines powering aircraft from Boeing and Airbus. This isn't about regional jets or niche platforms. It's about competing where the stakes are highest. From the outset, the ambition behind PD-26 has been clear. It's intended to power future wide-body passenger aircraft, heavy freighters, and even large military transport planes. With a bypass ratio estimated between 8.5 and 9.0 and a fan diameter approaching 3 meters. The design targets long-range efficiency rather than brute force. Engineers are aiming for a cruise fuel consumption improvement of up to 20%. Compared to older Russian engines like the PS90A, on paper, those numbers would place it much closer to modern Western standards than anything Russia fielded before. But the more interesting part is how they're trying to get there. Unlike many past Russian programs, PD-26 isn't being built from scratch. Instead, it's a calculated blend of what already works. Its DNA traces back to the PD-14, a smaller engine that achieved certification and now flies on the MC-21. That program gave Russian engineers something they hadn't had in decades: real, modern experience with civilian certification, composite fan blades, digital engine controls, and high-temperature turbine materials. At the same time, PD-26 borrows heavily from the much larger PD-35 program, especially its gas generator core and advanced turbine technologies. The result is a modular design meant to scale efficiently across multiple thrust classes. And that decision wasn't just technical, it was strategic. As of now, PD-26 remains in the pre-prototype phase. Ground testing is expected in the late 2020s, with flight testing planned shortly after. Even under optimistic scenarios, certification wouldn't come until the early 2030s. Yet despite those timelines, the engine is already being discussed as if it were inevitable. That's because PD-26 is less about speed and more about survival. And to understand why, you have to look backward. Russia's jet engine industry didn't start from nothing. During the Soviet era, it produced world-class designs like the D-30 and AL-31, engines that powered everything from civilian airliners to frontline fighters. But the collapse of the Soviet Union in 1991 shattered that ecosystem. Funding evaporated. Skilled engineers left. Factories aged without modernization. By the 2000s, Russia had become deeply dependent on foreign suppliers, relying on Ukraine for helicopter engines and Western firms like Pratt and Whitney and Safran for critical civil aviation components. That dependence worked until it didn't. Turning point came in stages. First, in 2014, when sanctions following Crimea exposed how fragile Russia's supply chains really were. Then, in 2022, when the scale of restrictions exploded. Export controls cut off access to advanced machine tools, electronics, and precision components almost overnight. Estimates suggested that up to 70% of imported inputs used in Russian aviation programs suddenly became unavailable. Civil aviation was hit immediately. Aircraft were grounded for lack of spare parts. Leasing agreements collapsed, and at the same time, military demand surged. Transport aircraft like the IL-76 and Il-96 became more important than ever, supporting logistics under wartime conditions. That pressure forced Moscow to confront a hard truth. Import substitution was no longer a policy preference. It was a necessity. In public statements, Vladimir Putin made that shift explicit. calling for full localization in defense industries without sacrificing quality. It was a bold demand, and many inside Russia quietly doubted it was achievable. But the direction was set. The PD-35 program was supposed to be the crown jewel of this revival. Launched in the mid-2010s, it targeted an enormous thrust class of up to 38 tons and was intended to power the joint Russia-China CR929 widebody. The engine incorporated more than 20 advanced technologies, from ceramic matrix composites to next-generation digital controls. In 2023, its gas generator core successfully ran on a test bench in Perm, proving that the core technologies worked, but geopolitics intervened. The CR929 partnership unraveled, and the justification for such a massive engine weakened. That's where PD-26 comes in. Instead of abandoning the investment, Russian engineers adapted. They scaled down the PD-35 core, paired it with a smaller fan and low-pressure turbine, and created a more practical engine tailored to aircraft. Russia actually plans to build. The modular approach promised to cut development costs nearly in half and shorten certification timelines. In other words, PD-26 wasn't born from ambition alone, it was born from compromise. Officially, the engine was unveiled in 2025. Within weeks, it received direct political backing, transforming it from a technical derivative into a strategic priority. The message was clear. This engine would move forward, delays or not. Plans began circulating for flight testing on modified IL-76 platforms, using a mixed configuration with older engines on 3 pylons and the PD-26 on the 4th. It's a cautious approach, but also a telling one. Russia isn't trying to leap ahead. It's trying not to fall out of the race entirely. Still, the challenges are immense. Production capacity remains a bottleneck. Even the PD-1 for Russia's most successful modern civil engine has struggled to reach more than a few dozen units per year. Precision manufacturing, especially for turbine blades and high-temperature components, remains constrained by sanctions and aging equipment. Skilled labor shortages persist as experienced engineers retire or leave. These aren't minor hurdles. They're structural limits that no amount of political pressure can fully erase. And yet PD-26 continues, because its value isn't measured only in thrust or efficiency. Geopolitically, it signals defiance of Western efforts to isolate Russian high-tech industries. Economically, it's meant to stabilize an aviation sector worth billions and preserve industrial jobs. Militarily, its dual-use design supports heavy airlift capabilities. Russia cannot afford to lose. Critics argue it's symbolic, a prestige project in a strained economy. Supporters claim it proves sanctions have forced innovation rather than collapse. In the end, PD-26 represents something larger than itself. It's a test of whether a modern, highly complex technology can be sustained under long-term isolation. Not whether Russia can surpass the West, but whether it can remain technologically relevant at all. The engine's first flight, whenever it happens, won't just be an engineering milestone. It will be a verdict on an entire strategy. And until that verdict arrives, PD-26 remains suspended between ambition and reality, quietly challenging assumptions that many thought were settled long ago. That tension between ambition and reality is exactly where the PD-26 story becomes more than an aviation project. It becomes a window into how Russia is reshaping itself under pressure. What looks like a technical decision on paper is actually part of a much broader shift, one that economists and strategists increasingly describe as a fortress economy. In this model, efficiency takes a backseat to endurance and access is replaced by control. The PD-26 fits neatly into that logic. Geopolitically, the engine sends a message far beyond Russia's borders. By pressing ahead with a high-thrust turbofan under sanctions, Moscow is signaling to non-Western partners that advanced aerospace development doesn't have to run through Washington or Brussels. This narrative is especially aimed at countries within the BRICS bloc and others navigating their own uneasy relationships with the West, even though the joint wide-body ambitions with China faded. The underlying idea remains: technological autonomy as leverage. PD-226 becomes a proof of concept, not necessarily of superiority, but of independence. Economically, the stakes are just as high. Russia's civil aviation sector has been hit from every angle: shrinking fleets, grounded aircraft, and rising maintenance costs. Airlines have been forced to cannibalize planes for spare parts, a practice that buys time but not stability. The PD-26 is meant to anchor a longer-term recovery, one tied to a broader push to field hundreds of domestically built aircraft over the next decade. On paper, this would keep factories running, preserve skilled jobs, and reduce reliance on foreign suppliers. In reality, it hinges on whether production rates can ever match political promises. Then there's the military dimension, which often goes unstated but is impossible to ignore. Heavy airlift has become a strategic priority, especially as operational demands increase and legacy platforms age. Still, skepticism persists, even within Russia. Analysts point out that sanctions didn't just remove access to components, they disrupted entire ecosystems of quality control, certification, and supplier accountability. Rebuilding that from scratch is slow and expensive. Parallel imports and indirect supply routes can fill some gaps, but they don't replace deep industrial integration. And while officials often highlight breakthroughs, production statistics tell a more restrained story. Output growth remains uneven, and delays are quietly acknowledged behind closed doors. This is where PD-26 becomes a gamble, not a reckless one, but a calculated risk. By scaling down from the ambitious PD-35 rather than starting over, Russia is betting that incremental progress can outpace isolation. The modular approach allows lessons from one engine to feed directly into another, spreading risk across programs. If PD-26 succeeds even partially, it could stabilize the entire domestic engine family. If it stalls, it may expose just how narrow the margin has become. What's striking is how little room for retreat remains. Unlike earlier programs that could be shelved or delayed without immediate consequences, PD-26 is now tied to national strategy. Funding, political credibility, and industrial survival are all wrapped into its outcome. That pressure cuts both ways. It accelerates decisions, but it also magnifies failure. In the coming years, attention will shift from announcements to test data. Bench runs, thermal limits, vibration profiles, and fuel efficiency curves will matter far more than speeches. A single successful flight test will be celebrated as a breakthrough. A setback will raise questions that can't be dismissed as propaganda. The world won't need to guess how this story is going. The results will be visible, measurable, and hard to spin. So when people ask what truly makes the West uneasy, it may not be the PD-26 itself. It's the precedent it represents. A reminder that pressure doesn't always produce collapse. Sometimes it produces adaptation. Whether that adaptation is sustainable is still an open question. But one thing is already clear. The era where Russia's aerospace ambitions could be dismissed outright is over. The real test isn't whether PD-26 flies. It's what happens if it does. And if it does fly, the consequences won't be immediate or dramatic. There won't be a sudden collapse of Western engine makers or a reshuffling of the global aviation order. What will change is something quieter, but far more important: assumptions. For decades, aerospace power has been tied to access. Access to global supply chains, to Western certification systems, to precision tooling scattered across multiple countries. PD-26 challenges the idea that losing that access automatically ends the game. That's why many analysts argue the real impact of PD-26 won't be measured in sales or exports, at least not at first. It will be measured in confidence. Confidence inside Russia's own industrial base that complex systems can still be built domestically. Confidence among non-Western states watching closely, wondering how vulnerable their own industries might be under pressure. And confidence, or lack of it, within Western policy circles about how effective long-term technological isolation truly is. At the same time, expectations around PD-26 are being carefully managed. Officials no longer speak in terms of rapid dominance or global market takeover. Instead, the language has shifted toward reliability, sufficiency, and continuity. That change matters. It signals a recognition that the goal is no longer to outcompete the West on its own terms, but to survive outside those terms altogether. In that sense, PD-26 isn't a challenger to Western engines like the GE90 or Trent families. It's an alternative path. There's also a generational aspect that often goes unnoticed. Many of the engineers working on PD-26 are part of a cohort that entered the industry. During the PD-14 program, they didn't inherit Soviet-era design philosophies directly. They learned within a modern certification environment, constrained, imperfect, but closer to international standards than anything Russia had before. PD-226 is their first chance to apply those lessons at scale. Whether they succeed or stumble will shape the next 20 years of Russian engine design. Still, the risks remain unavoidable. If certification drags on into the mid-2030s, the engine may enter service already technologically dated. If production never scales beyond small batches, its strategic value shrinks. And if quality issues emerge under operational stress, confidence could evaporate quickly. These aren't hypothetical concerns. They are the same pitfalls that have plagued complex aerospace programs worldwide, even under far more favorable conditions. Yet, despite all of this, PD-26 keeps moving forward. Slowly, methodically, without the fanfare that usually accompanies aerospace breakthroughs. That, in itself, is telling. It suggests a program no longer driven by image, but by necessity. A project designed not to impress the world, but to ensure that Russia can still move people, cargo, and power through the air on its own terms. In the end, PD-26 may never become a household name. It may never power aircraft seen at major international airports. But its significance doesn't depend on visibility. It depends on function. If it works, even imperfectly, it will validate a strategy built on endurance rather than integration. If it fails, it will expose the hard limits of isolation in an industry that tolerates very little margin for error. Either way, the message is already out there. Russia isn't waiting for conditions to improve. It's adapting to the conditions it has. And PD-26 stands as one of the clearest symbols of that adaptation. Not as a declaration of victory, but as a statement of intent. The kind that doesn't fade quickly, no matter how the final chapter is written. That intent becomes even clearer when you look at how quietly this program is being handled. There's no glossy rollout, no exaggerated timelines, no claims that the PD-26 will instantly rewrite aviation history. Instead, the messaging is restrained, almost cautious, and that restraint itself is unusual. It suggests the people closest to the program understand exactly how narrow the margin for error is. In aerospace, especially at this level, promises are cheap. Data isn't. What happens next will unfold in stages that don't make headlines. Metallurgy tests, stress cycles, long-duration bench runs designed to expose flaws rather than hide them. Each of these steps will determine whether PD-26 remains a political symbol or becomes an operational tool. And unlike consumer technology, there's no shortcut here. You can't rush an engine that's expected to operate for tens of thousands of hours without failure. Another overlooked factor is certification. Even if Russia certifies the PD-26 domestically, international acceptance is a different matter entirely. Without validation from Western aviation authorities, the engine's export potential remains limited. That doesn't make it useless, but it does redefine its role. PD-26 isn't being built to conquer global markets in the near term. It's being built to ensure continuity at home, to keep aircraft flying, factories operating, and logistics moving without asking permission. This is where critics often miss the point. They frame PD-26 as an attempt to catch up to the West, but that's no longer the real objective. The objective is insulation, resilience, the ability to function when access is denied. By that metric, even a technically imperfect engine can be strategically successful if it meets minimum reliability and production thresholds. And this mindset may be the most consequential outcome of all. If PD-26 proves viable, it reinforces a broader shift already underway across Russian industry, one where optimization is sacrificed for control and redundancy replaces efficiency. From an economic standpoint, that's costly. From a strategic standpoint, it's deliberate. The PD-26 isn't designed for a globalized world. It's designed for a fractured one. Looking ahead, the first flight will be symbolic, but the real verdict will come years later, when the engine is asked to perform day after day under operational strain, when maintenance crews, not engineers, become its primary judges, when availability rates matter more than press releases. That's when the experiment truly begins. Until then, PD-26 exists in a liminal space, too advanced to dismiss outright, too early to declare a success. It stands as a reminder that technological power doesn't disappear overnight, even under pressure. It adapts, reshapes, and redefines its goals. So the unease it creates isn't about fear of being overtaken. It's about uncertainty. About whether the tools long used to enforce dominance still work as intended. PD-26 doesn't offer an answer yet, but it forces the question to be asked. And in a world built on assumptions, that alone can be unsettling.